So we continue with the second part, that is electromagnetism, and now we are on the part of simple DC motor. Now simple DC motor, we need to understand it properly very well so that it has to be understood properly. Right, now we know that in our electric gadgets such as fan, washing machine, juicer, mixer, grinder, etc., an electric motor is used to produce rotational motion by the use of electricity. Thus, an electric motor is a device which converts electrical energy into mechanical energy. So, the main principle is that electrical energy is going to convert into mechanical energy. So, the fan, the grinder, the juicer, ये जो भी है जहाँ पे rotational motion हो रहा है, so that all rotational motion are going to be performed by a simple motor. Okay. So the principle is that a DC motor works on the principle that when an electric current is passed through a conductor placed normally in a magnetic field, a force acts on the conductor as a result of which the conductor begins to move and thus mechanical energy or work is obtained. The direction of the force of the conductor is obtained by the help of Fleming's left hand rule. So if I'm placing a conductor, so suppose I take this particular conductor और ये कंडक्टर को मैग्नेटिक फील्ड में रखा, तो मैग्नेटिक फील्ड में रखने के बाद क्या होगा, ये जो है इट इज गोइंग टू एक्सपीरियंस अ फोर्स ड्यू टू विच इट विल स्टार्ट रोटेटिंग. सो वील अंडरस्टैंड दिस पर्टिकुलर थिंग इन द further part. So you see that when DC motor, the main thing is that you are placing a current carrying conductor in a magnetic field, and due to that particular thing, so we are already seen that when a current carrying conductor is placed in magnetic field, it experiences a force. Okay, so this force which is going to be generated is going to move that particular conductor, and the movement of the conductor gives you a rotational motion, and then the electrical energy gets converted into mechanical energy. And for the direction of the conductor or the force which is going to be out there, we are going to use the Fleming's left hand rule. Construction and main parts. The basic construction of the electric motor is shown in the figure 10.24. The main parts of the electric motor are the armature coil A, B, C, D. So what you have is going to be this way. So let me see this. It will be like this, that this is a electromagnet over here, which, or you can have a permanent magnet also. The permanent magnet over here, which is having the north and the south like this. You are having a coil which is going to be placed like this. So this is a coil such that the coil can be named as A, B, C, D like this, and they are connected like this over here. Okay. So we have the armature ABCD mounted on an axle. So on an axle means there is a complete rod over here. Then this rod के ऊपर ये particular armature connected है, so that it can rotate. And moreover, there are okay. So this is this is the axle, and next is the split parts. S1 and S2 of a ring. So here there is a ring which is going to be like this. So there is a ring over here and over here. So the ring को दो पार्ट में कट करके यहाँ पे कनेक्ट किया. So this gets connected here and this gets connected to this part over here, and over here is a bush which is a connection which is not directly connected, but it is like it can touch, it can keep on touching, like it can keep on touching. Okay, so ये move करेगा तो भी ये move करने देगा इसको. Okay, this is not fixed, this is not going to move with it, but it is going to be such that अगर ये यहाँ पे है तो ये उसको move करने देगा, and ये इस stationary रहेगा. So this is going to be stationary. The brush is going to remain stationary, and this ring can rotate, remove like this, can rotate over here. So this is the slip ring or brushes over here. So this is S1, this is S2, this is brush B2 and B1, B2, B1. And connected to this are the battery terminals and also the key and okay, whatever that's a normal thing, a variable resistance. So here rheostat is there. So this is the structure or basic structure of the DC motor. So what are the things? Permanent magnet, north and south. So it can be a horseshoe magnet. It can be like this, a horseshoe magnet with the this. Suppose this is the coil ABCD. It just plays over here like this. So this is a permanent magnet. यहाँ पे north, यहाँ पे south, और ये coil बीच में. Okay. Or you can have two different also. One magnet here, one magnet here. इसका north pole इधर, south pole इधर है, जो हम लोगों को काम का नहीं है. यहाँ का south pole इधर, north pole काम का नहीं है. तो there will be force of magnetic field lines moving from here to here. The next what we have is a pair of copper brushes B1 and B2. So this is a slip ring, carbon brushes B1 and B2. These are the carbon brushes, and a horseshoe electromagnet NS, north-south horseshoe electromagnet, and a source and a battery over here. So this is the construct structure. दो magnet, ये coil connected to our armature, okay, or connected to a the axle. Sorry, this is the axle. Okay, rotor, and this is slip rings. They are split rings. They are split rings. Okay, there is split ring commutator. It is also called a split ring commutator. So, and these one are the carbon brushes. So B1 and B2 are the carbon brushes. Okay, and then comes the battery. So this is what the figure is about. So the armature ABCD is wound around a soft iron core and is placed in between the pole pieces of the strong horseshoe electromagnet NS. The coil is free to rotate about its axis. The ends A and D of the coil are connected respectively to the split rings S1 and S2 of the ring. The brush B1 presses gently across against the split ring S1, and the brush B2 presses gently across along the split ring S2. A DC source battery is connected across the brush B1 and B2 through a key and a rheostat. When the coil rotates, the split parts of the ring rotate with it, while the brush which are fixed remain at their position so as to remain in contact with the split ring. So that's a very important part. When this rotates, this also rotates. Okay, it is something like this कि अगर समझो यहाँ पे अगर मैंने ये मेरा coil है और इस जगह पे there is going to be some cylindrical part. Let me stick some cylindrical part which will be helpful. Yeah, you can take this. So this is like this. This is like A, B, C, D. Okay, I'll just mark it over here for convenience. So if this is like A, B, C and D. So it is given here A, B, C and D. So it is like this over here. This particular thing is connected like this. So when this rotates, they are going to rotate together. Okay, they are rotating together like this. Okay, तो ये पूरा इस तरह से घूमेगा. Now over here you can see that the carbon brushes are connected over here like this. Okay, they are connected like this, so that when this rotates, the carbon brushes are going to remain steady. Okay, when this is going to rotate, the carbon brushes are remaining steady. Is it clear? Have you understood this part? Right? So that's the purpose of this carbon brush. The carbon brush is going to keep the See, अगर ये कार्बन ब्रश कनेक्टेड होता बैटरी के साथ कनेक्टेड, दिस इज कनेक्टेड टू द बैटरी. अगर ये वायर के साथ में कनेक्ट होता या और ये ट्विस्ट होते रहता तो द वायर वुड हैव गॉट ट्विस्टेड एंड विल ब्रेक इटसेल्फ. बट व्हाट वी वांट इज दैट व्हेन दिस मूव्स द वायर शुड नॉट गेट ट्विस्टेड. सो दैट्स व्हाई ये कनेक्शन इधर है, तो ये जब भी रोटेट भी करेगा तो भी प्रॉब्लम नहीं आएगा. ओके, इट विल जस्ट इजीली रोटेट विदाउट एनी प्रॉब्लम्स. सो हियर एक कार्बन ब्रश, हियर एक कार्बन ब्रश. ये split हुआ है. I cannot split this, but yeah, there's a split over here. So there's a two different block. This is S1 part and the S2 part. Or I can mark it this way. Yeah, so it is. You can now see it. So it is like this. So the two part S1 and S2, and such that this S1 is connected to the brush here and S2 is connected to a brush here. Okay, so this is the way it is doing. Now let's see the working. Okay, the wheel can be mounted on an axle attached to a armature coil along its axis so as to rotate and the desired part of the machine where the motor is used. So of course we can put the axle in such a way that it is going to, अगर ये यहाँ पे ऐसे रोटेट कर रहा है तो एक्सेल आगे ऐसे भी हो सकता है, या तो उसको चेंज करके गियर्स वगैरह चेंज करके उनको ऐसे भी घुमा सकते हैं. तो that is a different issue altogether. Working in figure 10.25a, so that is in the next part of the thing. So let's see what happens. So we see over here, this is A, B, C, D. This is the poles over here. So the current is coming from here. The current is entering from here, going here, going here, going here. So current is going from A to B. A to B, the current is here. Now I am going to use leaving left hand rule. What is the direction of the current? This is the direction of the current, the central finger. So that's why it is the direction finger is like this. Okay. Now the north south is, this is north and this is south. So of course it has to go like this. Got it? So now what happened? The current is upwards. The direction of the magnetic field is this way. You can see my thumb is backwards. So that means that this one is going to go this way. It is going to go turn this way. Got it? So when I see the current over here, it is going to push this conductor backwards. Right? Now let's see over here. What happens over here? Current goes here, goes down like this. So current is passing from here, A, B, C. BC में कुछ नहीं होगा because BC में the direction of the magnetic field and the direction of the current is parallel to each other. We have learned that if they are parallel to each other, there was not going to be any kind of deflection. So if this and the magnetic field are parallel to each other, so there is no current, no force acting on this part because the direction of the current and the direction of the magnetic field is the same, parallel to each other. So we see this one. Over here, it is from C to D. When it is going from C to D, it is going downwards. So again, left hand rule. So this part, the current is downwards. The magnetic field is this way. So it is going to be this way. So magnetic field this way, right? The current is downwards. You can see the thumb is pointing forward. So this is going to push it forward. So you can see that when the current flows, this part is going backwards and this part is going forward, and this one is giving it forward movement. So ये भी एक ही मूवमेंट है, दोनों जो है दे आर गिविंग द सेम रोटेशनल मोशन. इट इज नॉट गिविंग लाइक ये आगे जाने दे रहा है और ये पीछे जाने बोल रहा है एंड दैट्स व्हाई इट इज गोइंग टू रिमेन स्टेडी. नो, द डायरेक्शन इन व्हिच दिस इज प्रेसिंग बैकवर्ड एंड दिस इज प्रेसिंग फॉरवर्ड. तो दोनों ऐसे ही मूव कर रहे हैं उसको. ओके, at the time both are going to give you a torque is being produced. Okay, this is a simultaneously, so it's a couple. What is formed over is a couple. We had learned about the forces couple. What is the couple? Like एक ये direction और दूसरा ये direction. So this is what the couple is going to be formed. So when the current is made to pass through A and B, it is going to give you a backward force. C and D will give you a front force. It forms a couple, and hence this is going to rotate. Clear? Now, once it is rotating, now what happened? This starts rotating. So when this starts rotating, you will find that at 90 degrees, it is going to become like this, such that the two split rings, okay, they are going to become up and down. They are going to come like this, up and down. Yeah, they are up and down. Whereas the brushes, the carbon brushes are over here. So they are not in contact with any of these. Right? Because they are not in contact with any of these, that's why the current over here will stop flowing. Right? So now when this particular thing comes up, ऐसे होने के बाद जब ये ऐसे होता है, so it was like this and now it has gone like this. So when this happens, the current stops flowing from this particular coil. But we know about inertia. What does inertia say? That it will remain in a state of rest or on motion. इसलिए ये inertia के कारण ये थोड़ा आगे जाएगा और जैसे वो थोड़ा आगे जाएगा इसको brush 2 के साथ connection मिल जाएगा. The B1 will get, see, the B1 was initially connected to S1. This is B1, this is S1. this B1 and S1 were connected to each other, but जैसे ही ये motion आया, so this was now in between the two, and then this came like this. So now the B1 is connected to S2. Okay, in this condition कोई connection नहीं है. जैसे ये थोड़ा inertia के कारण थोड़ा आगे बढ़ेगा, तो the B1 gets connected to S2 and the current will start flowing now such that it will enter through D. You can see the current will start flowing now such that it will enter through D, go to C, B and A. अगेन द सेम थिंग, यहाँ से जब भी जाएगा तो इधर से इधर जाएगा तो क्या होगा, डाउनवर्ड, और इधर अपवर्ड, और इसलिए रोटेशन कंप्लीट हो जाएगा. एंड इन दिस वे द रोटेशन विल कीप ऑन कंटिन्यूइंग. Are we clear on this? I'll explain once again. This is the condition. Okay, this is the condition over here that we have got this particular A, B, C, D. This is the split ring. This is the brush. The brush is connected like this. The current starts flowing. The current flows here. So there is a couple formed. Due to the formation of the couple, this is going to go downwards and this is going to go upwards. So this is going to move like this. As it moves and this becomes perpendicular here. ये पहले the parallel था to this one, to the magnetic field over here. Now it becomes perpendicular to the magnetic field. At that time, there is no current flowing. Because there is no current flowing, actually it should stop. But because of inertia, it moves further. When it moves further, it is coming in contact with the S2. When it moves to S2, then the current is now going to go in the opposite direction. That the direction will be DCBA. When it does happen, again the rotation will be formation of the couple due to the left-hand framing left-hand rule, and this goes down and this goes up. So accordingly, we will be having the motion available. So the current when it flows like this, so this is going to move in the direction as shown to you earlier by me. So let's see the working. In figure 10.25a, the plane of the coil is horizontal and the split ring S1 touches the brush B1, while the split ring S2 touches the brush B2. The brush B1 is connected to the positive terminal of the battery, while the brush B2 is connected to the negative terminal. When the key is closed, the current flows in the coil in the direction A, B, C, D. So that is what I showed you, A, B, C, D. So it was connected this way, like this, over here, connected like this, B1 connected to S1 and A, B, C, D से connection जा रहा है. The current in the arm BC and DA is parallel to the magnetic field. So these arms experience no force. So yeah, BC and DA are parallel to the magnetic field, so they do not experience any force. The current in the arm AB and CD is perpendicular to the magnetic field, so each arm experiences a force F is equal to IBL. Here L is the current in the, here I is the current in the coil, B is the magnetic field, and the L is the length AB or CD. According to Fleming's left-hand rule, the force F on the arm AB is in the inward direction perpendicular to the plane of the paper, and F on the arm CD is in the outward direction perpendicular to the plane of the paper. The force on the arms AB and CD being equal and opposite form a couple. Form an anti-clockwise couple, due to which the coil begins to rotate such that the arm AB goes in and the arm CD comes out. When the coil reaches the vertical position after 90-degree rotation, perpendicular to the plane of the paper in the arm CD out and the arm AB in, as shown in the figure 10.25b, momentarily there is no contact between the brush B1 and the split ring S1, or between the brush B2 and the split ring S2. So at this moment, no current flows through the coil and thus no force acts on the coil. Due to the inertia of rotation, so as I told you, it is because of the inertia of the rotation that now it is going to just move a bit forward, just a bit forward, so that it is making the contact. Now B1 will make contact with S2 and S1 will make contact with B2. So due to inertia of rotation, the coil does not stop in this position, but it continues to rotate. As the coil passes from its vertical position, the split ring S1 comes in contact with the brush B2, while the split S2 comes in contact with the brush B1. Now the current flows through the coil in the direction DCBA. The arm BC and AD being parallel to the magnetic field experience no force. On the arm DC, a force acts in the inward direction perpendicular to the plane of the paper, and on arm BA, an equal force acts in the outward direction perpendicular to the plane of the paper. The force is maximum, that is F is equals to IBL, when the coil turns to maximum. Coil turns by 180 degrees from the initial position. The forces acting on the arm DC and AB on the coil again form an anti-clockwise couple, due to which the coil remains rotating in the same direction. After rotation by 270 degrees, you can see यानी क्या था, ये अभी एक part था, this was 0 degree, okay, this was 0 degree, okay, I got this. उसके बाद this is going to move in this direction, it comes here 90 degrees. ये 180 degree हुआ, then again 270 degree, okay. So that is the 270 degree movement now. After rotation by 270 degrees, the coil reaches to the vertical position as shown in the figure 10.25D. Again, for a movement, there is no contact between the brushes B1 and split ring S2, or between the brushes B2 and the split ring S1. Hence, no current flows in the coil. But due to inertia again of the motion, the coil continues to rotate, and again it reaches back to its initial position, जहाँ से फिर से ABCD से current pass होगा. So note, the deflecting couple on a coil of a motor is maximum when the plane of the coil is parallel to the direction of the magnetic field, while the deflecting couple is 0 or minimum when the plane of the coil is perpendicular to the magnetic field. So this is a very important point. We can just read it once again to understand that what exactly they mean to say. The deflecting couple, that means the force which is acting on this thing, the force which is making it move like this, the deflecting couple, okay, this and this forms a couple. So the deflecting couple on the coil or the motor is maximum when the plane of the coil is parallel to the direction of the magnet. So this is the direction of magnetic field and this is parallel. So at this position, the force which is going to be acting will be maximum, and will be minimum when it is going to be like this, okay. While the deflecting couple is 0 or minimum when the plane of the coil is perpendicular to the magnetic field. It is perpendicular, it is minimum. The speed of rotation obviously depends on the magnitude of the deflecting couple formed by the force acting on the arms AB and CD of the coil. Deflecting couple is BA and I, where B is the strength of the magnetic field, A is the area of the coil, N is the number of turns in the coil, and I is the current of the coil. Hence, the speed of the rotation is directly proportional to these factors. So, speed of the motor will be dependent on the number of turns. It will be dependent on the strength of the magnetic field which is there. It will depend upon the area of cross section of the armature of the coil and the number of turns, and finally the current. So all these are the factors which are affecting the speed of the so anyways, we can also have this thing as the ways to increase the speed of the rotation of the coil. The speed of rotation of a coil can be increased by the following 4 ways. By increasing the strength of the current in the coil. So if I increase the strength of the current passing through the coil, then through this coil, automatically there will be increase in the, because if there is increase in the increase in the current, there is an increase in the force. Okay, current increases, force increases. Second, increasing the number of turns in the coil. If I increase the number of turns in the coil, automatically it is also going to be the same thing, because the magnetic field will be more. So, which is cutting this particular knot sub is going to be more. So, more the number of turns in the coil, the more will be the speed. Third, by increasing the area of the coil. If I increase the area of the coil, if I put a soft iron core वगैरह को डाल के करेंगे तो if you are increasing the area of the coil, then also it is going to increase. And finally, by increasing the strength of the magnetic field, if the strength of this magnetic field which is there, if I increase this, automatically the speed will also increase. Now here you can see that to increase the strength of the magnetic field, a soft iron core is inserted within the coil. The insertion of the core makes the magnetic field stronger and radial. But the radial field, due to the radial field, the couple acting on the coil remains almost constant during the rotation of the coil, except in the vertical position of the coil when the couple is 0. So it is seen that when you are increasing, so if you want to increase this thing at that time, by increasing this, you are increasing the magnetic field over here, and by increasing the magnetic field over here, the couple which is formed over here is also increased, hence increasing the speed. But when it is so due to the radial, now the insertion of the core makes the magnetic field strong and radial, okay, because we are inserting some magnetic field over here, so it is going to give you a radial, radiating out the field in all directions. But you will see that due to the radial field, the couple acting on the coil remains almost constant, because over here when it moving, so see, the thing is that the motor is not going to have something like this. The motor will be having something round part over here, okay, plus the magnetic field, if it is throughout, यहाँ पे पूरे जगह पे अगर magnetic field रहेगा, तो it will be radiating out in all directions. So the at any time there will be a position of the coil which is exactly perpendicular, or we can say which is exactly parallel to the field, to the magnetic field. So accordingly, what will happen, that there will be a continuous couple, maximum couple is going to be formed, and hence the speed of rotation will always remain constant in this case. So except for when it is in the vertical position when the couple is 0. But तभी inertia काम करेगा. Now, function of the split ring commutator. So this is a very important part. The split ring over here is very important, because if this would have not been split, okay, then what would happen is short circuiting. The positive and the negative both are getting connected to the same point, and they will short. The current will not pass through this. In fact, there will be a short circuit here. So when the coil passes from the vertical position, the direction of the current through the coil has to be reversed. Now suppose I do it this way. Suppose I do it this way. ये किस तरह से connect किया है कि B1 always give current to the S1 and B2 always get current to S2. There is no changeover. Then what would happen? The current is coming from here, coming here like this and going back. And when it rotating, now the current is not going to come from here. The current is still going to come from here only. And if it is coming from here, now what will happen? Due to Fleming's reference rule, so you can see this current is going to be down this direction. The direction is this way, so this is going to downwards. So ये जो पहले ऐसे ऊपर जा रहा था, उसके बदले अभी नीचे जाने का ट्राई करेगा. Let's see once again. A to B going this way. So Fleming's left hand rule, current upwards, magnetic field this way, it is pushed this way, so this is pushed towards me. So now it comes here and goes to this part. Now this is A and this is B. It is going this way. Okay, the current is going in the upward direction like this. Now it is going to be like this. So current जो है वो ये direction में, magnetic field direction में. तो अभी भी वो मेरे side पे ही आ रहा है, यानी ये जो इतना घूम के जो इधर आया, वो वापस घूम के इधर ही जाएगा, ऐसे ही जाएगा. So the motor will run like this. Instead of running like this in a rotational manner, it is going to be like this. It goes from here to here and here to here, here to here, here to here. Got it? So the split ring commutator over here makes sure that the direction of the current inside the coil is continuously reversed. पहले ABCD फिर DCB है, पर DCB है कभी ये इधर आ जाए तभी DCB है. Okay, when it is coming and rotating here, this becomes D, this becomes C, this is becoming A, and this is becoming B, and this is becoming A. So अभी और ये S1 के बदले S2 हो जाता है और ये S1 हो जाता है. Current will flow from here S2, go to D, C, B, A here. So the direction is going to be the same for rotation. The rotational direction of the rotation will remain the same. It is going to keep on moving in this direction only. If the split ring would have not been there, it would have moved like this. It will just go like this, okay, turning like this, okay. So whenever the coil passes the vertical position, the direction of the current through the coil has to be reversed so that the coil continues to rotate in the same direction. Okay, the direction of the rotation of the current has to be reversed so that the coil continues to rotate in the same direction. This is achieved by the two split parts S1 and S2 of the conducting ring, which reverses the direction of current in the coil, that they are called as split ring commutator. Now, transformation energy in a DC motor is that in a DC motor, the electrical energy supplied by the battery to the coil is transferred to the mechanical energy which rotates the coil. So the conversion of energy is in the DC motor is from electrical energy to mechanical energy. So that is about the DC motor. Very important part. They do ask you to draw this figure. This figure is very important. They ask you to draw this figure. They ask you questions regarding the movement के invert outward जो मैंने बताया the Fleming's left hand rule के हिसाब से they ask you questions based on that. So very important part, must know kind of a thing. So see to it that you understand this thing properly, right? So that was about the DC motor. I think I'll stop this video over here and continue the next part of the chapter in the next video. Thank you.